Good morning, Mr. H here. We are going to be diving into the Unit 5 and 6 Redemption Quiz Preview today. Now, I'm going to tell you, it's a chunker. I did this on purpose because it lets me give you a few more problems to be able to work through with me. The test itself will not be this chunky. It's still going to be a little chunky. I think it's 23 questions if I'm remembering right. You're looking at this, you're going, holy crap, Hardy. 76 minutes. It's not going to take 76 minutes. Okay, I'm going to go in depth on some of these things. And I would highly suggest if you haven't worked through any of the problems yet before you're watching this video, that you either watch the video, then go through and try and do it on your own. Or stop me right now, go try to do it on your own, okay? And then if you're getting stuck, check out this video. But no matter which way we do it, we need to try and work both in because this is kind of important. So, okay. Now, yours is going to look a little different than mine because I'm in the teacher mode here, but the questions, we're basically going to be looking at the same things. So let me kind of get us rolling here. So, okay, first, right up. Got to go back in the bank here. Graphing exponential and log functions. Okay, graph the function on the axes below. You must plot the asymptote in any 2 points. Okay, a couple things to remember here. So I grabbed my calculator because I want a little help on this. And we go to y equals, and we type in what we see. Okay, so once I do that, I'm interested in the chart. And I'm interested in the whole numbers. So I'm going to zoom a little more here. Okay, so I look at this, and I go, so I see negative 1, 1. So negative 1, 1. And I see 0, 2. Okay, but here's what I've got to keep in mind. Where's the asymptote? Where, if I look at the graph, is my graph going through and getting really close to but not touching? Looks like really close to 0. If I keep scrolling, I'm getting really close to 0. There's my E even that's telling me I'm getting close to 0. So my asymptote is horizontal. Exponential's horizontal, logs is vertical. So horizontal. And that would be at 0. Now I can go back and look at my graph for a minute. Do those look similar? Yeah, they do. That's what I want to roll with. Bam, okay? So when we're doing these, that's going to be what's important. Now, again, here's another exponential. Again, it's about typing it in correctly. The x minus 5 is all up in the exponent this time, so make sure it's all there. I can look at the graph for a minute, and I'm like, all right, still looks like it's hugging the asymptote. Now, again, let's think about this, because you never know on the quiz, it may be different. If there's a plus or a minus down here at the end, that's going to represent an up or down shift. That will change your asymptote. So here, we're still a horizontal asymptote. In this case, it's still at 0 because I see where is it hugging, or I can use my chart. And then I just pull my chart. Oops, too far into the negative here. Find me some whole numbers, hopefully. There we go. So we got 5, 1. And we've got 6, 3. Okay, does it look pretty similar? For that part, it does. And we're rolling. Okay, so let the calculator help you. Evaluating logarithms. Okay, what's the log base 6 to 216? We've talked about this before. Okay, change of base. Log big divided by log little. Or if you can do it in your head, 6 to what power equals 216? That's also an option. So change base gets me the answer. Or I can just start messing with exponents, hoping that it's a whole number answer. And if I see it, it works that way. 3. And so I just keep, you're like, okay, log big divided by log little. Dang, Hardy, is 3 going to be the answer on every single one of these? Well, no. Again, just doing change of base. Okay, evaluating logarithms. Let's make it a little more challenging here. What is the value of log 1/10? Now, if you think about that for a second, first question you've got to remember is, what is my log base? What's my little number that's normally down here when I don't see one? It's 10. So log 1/10, oh dear, I got too many of that going in here. Log of 1/10 divided by log of 10. Now you might be saying, well, Hardy, I thought you said that it's big divided by little. 1/10 isn't bigger than 10. Physical size. Okay, this 1/10 is bigger than my little tiny subscript down here. Maybe you think of it as log right divided by log left. Log big divided by log little. There's lots of ways to think about it, but what you got to remember is it's always this one goes first and the little number goes after that. And this makes sense. You're like, oh yeah, 10, if I flip it, it's 1/10. Okay, I get what he's doing here. So we just keep rolling here. Now notice we're just flipping along here. I wish I'd have paid attention to the time as I was doing it. Ooh, what's the value of natural log e to the 6th? Now I should be able to do this without the calculator. Why? Natural log and e are inverses. They cancel each other out and just leave me with what's left. Now if you don't remember that, all is not lost. Okay, natural log is right next to the 4 on your calculator. So natural log, you're like, where's e? Second and natural log. See, there's the e right there. Put in the 6. Okay, you get the same answer. Not trying to make this rough on you. Just got to do a little thinking. Okay, all logarithms. Okay, condensing logarithms. Reminder, let me get this out of here. We're gonna create a little mini help sheet here. And if you haven't done this before, I would highly suggest it, because as you're writing the help sheet, you're seeing it. Hopefully you're speaking it. And then you're working with it. So you've got all these different things that's making your brain think about it. So when we condense, okay, add becomes multiply, subtract becomes divide, and we do those from left to right. And then coefficients turn into exponents. And that's the part we're going to do first. When we're condensing, we do coefficients first, and then the add and subtract stuff second. So I look at this, and I go, okay, move this up a little bit so I got room on my paper to work. So I look and I go, okay, so that q is going to turn into an exponent. This is going to look weird. And that 3 is going to turn into an exponent. So I look at that and I go, okay, so now what? Well, now what's left? The only thing that's left is plus turns into times. And when we're condensing, we want logarithm at the end. B to the q, that plus becomes times k to the 3rd. That's my answer. You're like, that's my answer? Yep. So they already got the log part done for me. I'll use this, even though you've got some options with this. So like if I do b, I can either hit this to get into my exponent, okay? Because watch this. If I hit this, there's the exponent. I put in my q. Hit the right arrow to get back down. Then times k. And if I want to do an exponent, the other way I can do it besides hitting this is if you hit Shift and 6. That's the natural keyboard way of doing an exponent. So Shift 6 works, AB works. 3. That's all I need. And we're good. Okay? So as we're doing these, that's kind of what we're doing. Now, condensing. Oh dear. There we go. Same idea. I'm looking at this and I'm going, okay, let's see. Condense. Let me move that down a little so I can have some more paper room. So I look and I go, okay, so same thing. Exponents become coefficients. Log d to the 4th minus log q to the 5th. Notice I didn't take the negative with me in my exponent in the fifth. The signs need to stay where they're at. Just the numbers, what you're taking. And now minus becomes divide. Log d to the fourth divided by q to the fifth. Okay, log, let me get my little thing out here. D, again, I can use this to go to my exponent, divided by q, or I can do shift 6 to get that to the fifth. Telling you, people, this is going to be chunky, but this is a quiz you absolutely can do. Okay, expanding logarithms. Now, when we expand, everything flips on what we just did. Again, note card's worth it, I'm telling you. So when we expand, it's all these rules except they're the opposite. Multiply becomes add. Divide becomes subtract. We're going to do these first from left to right. And then second, exponents are going to turn into coefficients. Exact same stuff. Put this on a note card. Okay, enough of my little reminders like that. So I look at this and I go, okay, expand it. Expand means there's going to be multiple logs. So I look at this particular problem and I go, okay, so what do I see? I'm going to rewrite this originally because I want you to see something, a little detail in here. Oh, gee, it'd help if I wrote the right problem, wouldn't it? All right, just a sec here. We only want the condense. There's the expand. Okay. So we've got log x times y cubed. See, that little multiplication dot's there, and sometimes we forget that. So, do I see any multiplying or dividing? I do see a multiply. So log x plus, the times becomes add, log y to the third. Every term gets a log now. We're expanding, we're stretching this out. And so now my last thing is, do I see any exponents? If I do, they become coefficients on that term. 3 log y. Okay? Again, if you just follow the order, you're going to know you're done when you get these situated. So here, and let's get our keyboard out and ready. Log x plus, again, the keyboard, or there's a plus symbol on your little keyboard there. 3 log y. Should we type it in correctly? And we're good. All right, let's see here. Let's get another expand problem going here. I don't want to do the same one. I need something more creative. Okay, there we go. So one more of these. So again, I look at my problem here. I'm going to move me. I think that is going to help us immensely here. That's so much better. Okay. So I look and I'm like, okay, log x to the third over y. Run through the order. Do I have multiply? No. Do I have divide? Yes. Log x to the third minus log y. Got to have logs on each piece. And then do I have exponents? 3 log x minus log y. And it really is that straightforward. But again, I said I wouldn't say it anymore, so I won't. Okay, expanding logs. Let me see if it's, okay. Ooh, bigger one. Okay. I'm going to take away the note card for a bit. I want us to have some room to work with here. So let's see. What do we got here? So we got log y times x to the third over z squared. Okay, now we got to do all the things. We got multiply and divide. So what do? Just do the one that you see first. So log y plus log x to the third divided by minus log z squared. Okay. So now, do I have anything left? I do. Those pesky little exponents, they need to move. So nothing on the first term, it didn't have an exponent, plus 3 log x minus 2 log z. And we're in business. Log y plus 3 log x minus 2 log z. Boom. Rolling. All right. So away from the logarithms for a little bit. Now we're going to solve exponentials. You're like, oh, great, Hardy, sounds wonderful. Okay, reminder, inverses. Okay, when we're talking about inverses, let's get a new card going here. A log and its base are inverses. Natural log and e are inverses. So when I look at 10x equals 39, or 10 to the x, equals 39, I cannot divide by 10 because it's not 10x, like I just misspoke. Instead, we're going to take the log of that value, like we did here. Whatever we do to one side, we do to both, because again, this still is algebra. This is still like adding, subtracting, multiplying, or dividing to both sides. Whatever we do to one side, we do to both. So over here, I get x, and over here, it's change of base. So I grab my calculator. I try to stay out of the bright lights. Log 39, log big, divided by log little. Rounding the nearest hundredth, 2 decimal places. So 1.59, and that 1's not going to change anything. So 1.59. Pull it. Okay. And so as I do these, oh, look at this one. Ugh. You're like, Hardy, that looks kind of nasty. It's not bad. It's not. You're like, says you, the math teacher. Yeah, says me, the math teacher. 48 times 2 to the x over 3 equals 48. Okay, first job. Isolate your exponential. In the first one, it was isolated already, so I didn't have to worry about that. For this one, I got to get that isolated first. So first job is to get that 48 out of there. And since I'm multiplying it, we're going to divide. Now my next job at working on getting x is to get this 2 out of here. But again, the x is an exponent. So I have to use my logarithm of this same base to get there. So log base 2, okay. So we got log 1 divided by log 2. Because again, big over little, right over left, however you want to look at it. You're like, what? 0. Yep, 0. Now this is a normal fraction. What's the opposite of dividing by 3? Multiplying by 3. X is a big old fat nothing? Really? 0? Yep. Okay. So again, don't make life complicated. We're getting there. You're like, oof da Hardy. All right. What do we got next on the list? Oh, exponential with bases. Okay. So remember, with these, before I can solve them, these two values, the 27 and the 3, have to be the same. So the easiest way, we're hoping, is that I can turn the bigger one into this number to some power. So can I do 3 to some power and get 27? We're certainly hoping so. 3 squared, 3 to the third, 3 to the third. So here's what this is going to look like. 27 is 3 to the third. So same value over here, I'm just giving it a different base. And the reason we did that is once our bases are the same, I can exponentiate. Well, I'm not exponentiating really here, I'm using logs, but I'm using that log as an inverse to get to the exponents, to get to the point that I'm here. And now I'm just doing algebra 1. Oh, gee, 3 times 2 is 8. Yep, you didn't see that, right? You didn't see that. And now since we're doing Algebra 1, I'm going to kind of zip along here a little bit more because I don't know how quick some of your attention spans are going to be with me as I keep rolling through here. All right, 3. And you always can double check these answers by just plugging it into the calculator. You know, if you plug in the 3 as 27 squared, the same thing as 3 to the 6th, and the answer is, yeah, it is. But that's how we're going to deal with those. Now, what happens if, oh, I don't get a base that I can do that with? You're like, but wait a minute, 125 squared. Well, that's a lot bigger than 625. Hardy, I can't do that. Is this no solution? No, it's not. Well, what do I do then? I'm going to need to find a common base that both of these can be taken to. So we're going to take a number that's smaller. Now, I notice on this particular one, it's going to be a small number, 2, 3, 4, 5, something like in there. But I notice these both end in 5. So let's play with this. Okay, 5 squared is too small. 5 to the 3rd is 125. Okay, let's keep going. 5 to the 4th is 625. What does that mean to me? That means I can change the 125 into 5 to the 3rd, and I can change the 625 into 5 to the 4th. Okay, the exponents stay there. I'm just going to have a new one up there with it because my bases are now the same. And the way we saw in our last problem, using my log on both sides, because again, this is still algebra, lets me get rid of that and take this back to Algebra 1. And the nice thing about watching this on video is going to be, if I start going too fast, you can pause me, you can rewind me. I don't know if they can do it in slow-mo where I talk like this, but that'd be kind of amusing, you know? So let's see here. 9x equals 0. If we divide any 0 by anything, we're going to get 0. Is this sensible? Let's find out. See, I'm bound. One of these I know I'm going to screw up. I know that's sad to think the math teacher's going to screw something up, but it happens. All right. Write the log as an exponential equation. You do not need to solve for x. Okay. So when we're doing logs to exponentials, all right, where did my note card go? Okay. So log to exponent. And this is a good study strategy no matter what class you're doing. If you have something where there's going to be steps involved, so maybe here, maybe science, you're doing experiment things, maybe you're taking a cooking class and there's certain things you're doing with a recipe or something like that, actually sitting and writing down what the steps are naturally starts to get it back working in here. So log to exponent, here's the way I want you to think about this, okay? So we have a log, and I like to actually put numbers in for these things that I know are going to work. So the example I have is going to work out well for me because I know my system already. But you maybe it's going back and looking at your notes and grabbing an example of that and putting it on your note card. Might be a good way to do this. So like for me here, okay, we all know that 5 squared equals 25. The logarithmic version of that is my base to my exponent gets me my answer. Because when I'm looking at this is asking me 5 to what power is 25? Well, 2. Okay, 5 squared is 25. So now let's see if we can manipulate this into doing the same thing. So I look at this, I'm like, okay, so there's log 5. So let's see, that 5 came from here. So I'd have 5 first, okay. Then my exponent, okay, now where was my exponent? So log, the exponent's the equals side. So in this case, 3x is going to be my exponent. Because again, I'm just looking, my log, I'm looking at my example and I'm saying the equals of my log is the same as my exponent here. The equals of my log is the same as my exponent here. Okay. Equals. And the only thing that's left is the answer. So I look, the answer is the same as what's right next to the log. You're like, really? Is that going to work? We're going to find out. Okay. Just using, and the same way they do here, they use it with the generics, okay? A, B, and C. Now, maybe this makes more sense to you. Maybe you put that on your note card as you're going through the review. But that's what I'm talking about here. And I talked a little bit last week during one of our meets at the beginning where I'd like to do my little inspirational things that we need to do less trying and more training. This is your training, okay? This is our training regimen. Going through this review, making a note card, thinking about the stuff we're struggling with and going back and doing it again. Just like when you're getting ready for football season, okay? You're lifting, you're getting stronger so you can push people out of the way. Basketball, maybe you're working on your agility so you can breeze around somebody. Music, maybe you're working on playing that one last finish with the drum so you can hit it on that last note. But you're training, okay? We can't take it all on at once. We got to do it in little pieces. And that's what we're doing as we work through this. So look at it more that way. You're training. When you train, you're going to feel some pain. You're going to have some frustration, but we don't quit. We don't go, well, I tried it. What? We're not training. We're not trying. Trying, you can quit pretty easy. We're training. There's a goal here. What's our goal? Our grade's going up after this, and we're doing what we have to get there. All right, end of the little speech there for the moment. So let's take a look at one more of these. Now this time, okay, we've got the log, so we're going to go to an exponential. So again, let's take a look at this and roll from here. All right. Oh, well, Hardy, I got a problem. What? Well, my base number for my exponential, that's what I'm trying to get to. I don't have one. What number's right here when we don't see one? No, not 55, 10. Okay. 10, we know we're going to an exponent then. Okay, 10 to what? Where's our exponent at? Exponent is over on the other side of the equals. 3 equals. And then our answer, okay, is always this value right next to it, 5x 2. Okay. Base, yes. Exponent, yes. Answer, yes. And one other thing I'll mention as we do these, if there's a section, okay, let's say there's a section, let's say there's 2 or 3 problems, you're like, Hardy, you've explained this 5 times, I still just don't get it. That's okay. Okay, you're gonna have something, you don't have to be a perfectionist on this entire thing to get where you need to be. But as long as you're trying to keep working at it, you're gonna get there. So, okay, adding rational expressions, oh boy. Okay, now we have all our help sheets for this stuff. When we're trying to add, subtract, all those things. First thing we need is a common denominator. Here's where we're lucky this time. It's common already. Don't make this harder than it needs to be. Okay? So when I go to type this in, since these are the same, all I have to do is combine like terms up in the top. So 3x and 6x is 9x. 4 minus 9 is negative 5. And when you hit the division button, oh, now look at what happened. You're like, wait a minute, Hardy, it's making a fraction there. That's not what I want. How do I fix that? Okay. Here's how we're going to fix that. If you want to make sure all this stuff on the top stays in the top, the program wants you, okay, to put parentheses around it. Say, hey, this stuff needs to stay together. So my numerator, parentheses. One bad thing about no paper, but hey, we adjust. That's why we do these videos, right? Divide, Hardy. Divide. Now that's what I want. And my denominator is already equal, so I can just leave it. Do you have to have parentheses around it? Does it look like it's in the right form? Yeah. If you put the parentheses, is it wrong? No. Okay, and we're good. So we just have to tell the program what we want to do. So I'm going to be able to tell which one of you actually watched this later, and you're not sending me messages like, it won't. Nope, you didn't watch the video. Okay, combine the following fractions and get into reduced form. We are not as lucky this time. We do not have a common denominator, so that's my first job. You know what I'm going to do. Help sheet. Duh. Okay. Now, coefficients. Okay. Again, just looking at this part right now, I do have a coefficient. So 6 will be part of my new denominator. Variables, no pluses or minuses. Largest exponent. Well, no pluses or minuses, but the exponent is the same on both. It's just 1. So 6x. and there's no parentheses. 6x is my common denominator. So when I go into building mode, remember, we're just looking to see, hey, how do I get from here to here? Okay, whatever's in the numerator is still there. But the question now becomes, what do I have to times this by to get this? You're like, well, nothing. And that's true, but I always like to put something in there. So the question now becomes, what? Well, what do you multiply to get the same thing back? You multiply by 1. Now I do it on the next one, okay? I've already got the x. Oh yeah, when we check things off. I didn't check off the 6. So since I didn't check off the 6, that needs to be multiplied into my numerator, okay? So it's like a puzzle. Whatever pieces we don't have, we add, okay? We're kind of creating our own. And so now I'm just going to simplify this. So 7 plus 48 over 6x, 55 over 6x. Now, before you put that in as an answer, when you get to the end, and not until you get to the end or at this step, you always look to see if you can reduce something first. So I try 55 over 6. I put it in my calculator. I get math, and I even do math enter if I have to. So 55 divided by 6. Now I get a decimal. We don't do decimals. Math enter. I still get 55 over 6. That's the answer. So 55 divided by 6x. If it looks like your answer, oh, and it does, we go with that. We got it. You're like, oof, to Hardy. All right. So again, now this is real similar to the last one. Do I want to keep going? I'm just going to whip through this one. I'm not going to show my age by trying to deal with the song that's going through my head right now, but okay. So 5 over 7x plus 9 over 8x. Do the help sheet in your brain. Coefficients, 7 and 8. If you're not sure, make a list with 7s and 8s, or don't just multiply them. Remember, and again, if you have your help sheet, it's right on there. If you go to math, over to numeric, sorry for my glare. Oh dear, math, numeric, LCM. You can take your 7 and your 8, but you have to use the comma in between, right above the 7. Okay, Hardy, I could have just multiplied and it's 56. That's not true every time, though. And I have my variable. Keep what I have. You notice I'm saying the same things over and over with this. It's amazing how that works in math. 7 times what gets me to 56? 8. We put an 8 in there because 7x times 8 is 56x. We're building. Okay? 8 to get to 56. 7. I already got the x. And now it's just simplify. 40 and 63 and 103 over 56x. Do your quick experiment in the graphing calculator to see if it can reduce. All right, let's see. I'm not going to do all 3 of these. I'm just going to figure out. Ooh, that's good. Okay. So here we crank it up a little bit. A little bit. First thing, oh, that's not nice of Delta Math. We know we got to put parentheses around this stuff, right? So we're not that person. So I get to here and I'm like, okay, run through your checklist. Just looking at the denominator right now. Coefficients? Nope. Single variables? Yep. Okay. Parentheses. Just like that. Bing, bang, boom. We got us a common denominator. Putting in that time helped. So now I got what I've already got here. That hasn't changed. So you're like, dang, Hardy, I'm going to need paper when I'm doing this. You're right, you are. Now just check off what you have. I already have x. I need the x minus 9. Over here, I already have the x minus 9. I need the x. Now we're going to have a little cleanup to do here. So we've done the hard part. Now we just got to make sure we take enough time to make sure we don't screw up the easy thing. So a little distributing. Now over here, be careful. this is a minus. Okay, I'm actually going to move this x. I'm going to move it over here. And we talked about before, when this is a minus, I like to put the minus with my coefficient out front, because otherwise it's too easy to distribute this value and then forget about the minus and it not work. So here, that's a negative x, so negative 5x squared. Negative x times 7 is negative 7x. And we go ahead and we combine our like terms. So let's see here. Negative 5x squared, 7x minus 7x cancels. Minus 63. Now, make sure, can I factor this? It's not a difference of squares, because I kind of remember that when it says 5 and 63 don't have anything in common. I mean, I suppose I could take out a negative, but I don't need to. So I think that's the answer. So remember, since I've got more than one term in each the numerator and denominator, I've got to remember to put in my parentheses here. And then when I divide, now it's looking more like what I want it to. And again, you can use their keyboard. I'm just using my regular computer keyboard when I'm doing it for most of these. Make sure that looks the same. Now this ought to be interesting. Okay. Yep, so they had it. I just had the parentheses. They had the same thing. So now some of you may say, well, what if I took a negative out and I just changed the signs on those? Would it give me the same thing? Yes, it would accept that as an answer. All right, let's do one more of these. I think this is the one I wanted. Yep, that's the one I wanted. Now this looks easy, but I've got to be careful still. Because when I look at this and I go, okay, so 2 over x minus 2 minus 7. So I look at that and I go, well, the other thing's not even a fraction. Make it 1. Now here's the good news with this one. By making that a fraction, I can look at this and go, oh, well, my LCD is going to be really easy because coefficient, parentheses, there's no crossover. I don't really have to think about anything. I just got to remember that that 7 really is a fraction. Why is that important? Because now when I go to build, I got the x minus 2. Okay, I'll put the 1 in there. But over on the second one, it reminds me there's a fraction. I still have to build. I still need this x minus 2 up here. And since it's minus, I need to change this. So I remember to distribute the negative all the way through. So at this point, 2 minus 7x, negative times negative is plus 14. So negative 7x, 2 plus 14 is 16. And I'll make one other suggestion while I'm typing the answer in here. If you're doing some of these and you're like, okay, Hardy, as you're talking through it, I get it. But when I get to a quiz, I don't get it then. What's going on? The reason is you hear me talking all the time, but during your quiz, I don't talk. It's about the only time I don't talk. I get it. We're making jokes. But you've got to do the practice on your own without me talking sometime. So maybe if you haven't been doing the worksheets as we go along, now you go back with something like this and go, okay, let me go back to the adding things. Try a couple of the problems because you have the answers and see if you can do it on your own with your help sheet, with just what you remember from me. If you can, you're ready. If you're not, you need to either ask me questions, and hopefully it's not Sunday at 3:55 when you're looking at this, and kind of keep at it with things. Again, that's part of your training, okay? I appreciate the fact that you're trying right now, but we got the training part. And if I put the 1 in here with my x minus 2, it's not going to hurt anything. Awesome. Okay. Multiplying rational expressions. Thankfully, we're getting back to the easier stuff here. You're like, easier stuff? Holy crud, Hardy, what is that? Some factoring. We've been down this road, people. This ain't no new rodeo. So okay, 10x squared minus 40. Oh, where's it at? Where's it at? Factoring help sheet. There it is. You're like, help sheets for everything. You've got them. Use them. Is there a greatest common factor? Do all terms have something in common? 10 and 40? Yeah. 10. Okay. Take the 10 out. X squared minus 4. Ooh, but wait a minute. Look inside the parentheses. They're still squared there. Can I factor that? Could it be a difference of squares? Yeah, it could be. You're like, wait, I could have to factor something out and have a difference of squares? First plus second, first minus second. Some of you are trying to train for an entire marathon in like 2 days here. It's doable. It's just going to hurt as we're doing it. So, okay, there's my factored first part. Then I look down at the next one and I go, okay, I can take a 5 out of each of those. Ooh, now do I take out x squared or x to the third here? And I'm asking this question purposefully. When we're factoring, it's the smallest exponent. LCD, it's the biggest, so I got to keep these straight. So 5x squared. So what's missing here? I got 5. X to the third, I got squared, so I need one more. Then 5 times what is 35? 7. And I already have the 2 x's, so I don't need another x here. So, okay, 5 squared x minus 7. All right. Let's keep it rolling here. X to the fourth minus 49x squared. You're like, ooh, now Hardy tried to pull a fast one on you there. You caught it, though. You caught it. Do they have something in common? That's always the first question. The answer is yes. X squared. Okay. If I got 4 x's, I need 4. I got 2. I need 2 more. The next one, I already got the 2 x's. I need the 49. You're like, Hardy, you did it twice in one problem, you dirtbag. You can say dirty things like that behind my back. I don't hear you. Now, I have little ringings in my ear sometimes, so I know you're doing it. I just don't know who's doing it. X and 7. Because, again, you have all the squares on your help sheet. You're using it right? I hope so. X squared, x plus 7, x minus 7. Or maybe even when you're getting ready for a quiz or something, if you're doing this side work, make note of what section it is you're doing, multiplying rational expressions. And you've got another example there when you're doing the quiz. Just another helpful hint. Okay, last one, just a plain old diamond problem. Hallelujah, something normal. All pluses, we love that. So we're multiplying to 14 and adding to 9, 7 and 2. Okay, now we get to do the fun part. Canceling, reminder, canceling. Vertical, okay, top to bottom in a fraction. Diagonal, okay, we just don't do horizontal. We don't do sideways. So x minus 7, x plus 7, x plus 2. Okay, let's see what we got left here. 10x squared over 5x squared. Anything else reduce? X squareds, they're not bonded with plus or minus, so I can hack them even though these aren't identical. And 10 divided by 5 is 2. You're like, I did all that to get to 2? Are you kidding me? Oh, shoot. What did Mr. H do wrong? See, I get too cute sometimes here myself. Did I just come up? Oh. Now, some of you might be making fun of me at this point, and you should be. Well, not really. I got going so quick that I didn't see that x minus 2. And if I'd have taken the time, I did all that work right, and I forget that. It's a good lesson. I wish I could say I did that on purpose to test you. I didn't. I screwed that up. So at least you got to see that now, okay? Take your time when you're writing, especially when you've canceled a bunch of stuff, or it can get kind of ugly. All right, let's do one more of these. Okay, good. We got a division problem. That's what we're hoping for. Okay, so I look. First one looks like a diamond, because it is. Multiplies to 18 and adds to 9 would be 6 and 3. I've done my training. Okay. I look at my denominator. Anything in common? Yes. They're both divisible by 7. I take out my 7. 7 goes into 42 6 times. Now, division. When we divide, we flip the fraction after the division sign. So this really, when I'm looking at it, the x is on top, x isn't factorable, over x squared minus 9, which is factorable. It's a difference of squares. I square x to get x squared, I square 3 to get 9. So I got 3x and I got 3 is my first and second. So x plus 3, x minus 3. And at this point, I can't say it enough, you just keep, okay, I put it up here and said help sheet, use it. Okay. Now, this time I'm gonna be more careful when I cancel. So x plus 3, okay. X plus 6. Okay, now let's really watch it this time. X, 7, x minus 3. So I have a question for you at this point. Can I cancel the x's? I better be hearing no's. My ears are kind of ringing. I think I'm hearing no's out there. No, I can't. Why? This is bonded, this isn't. Okay, this is a singleton. This is in a pair. It's in a relationship already. We're not going to wreck relationships. I think we got this one this time. So let's find out. You have to remember the parentheses on the x minus 3 here, though, because if you just type in 7x minus 3, that's different. I wouldn't be distributing the 7 through. So just don't make some of the same mistakes that I do at times. Oh, hallelujah. We're back on track. Okay. All right. Least common multiple. We're down the home stretch, people. What's the least common multiple of 5 and 6? Okay, remember, 2 ways to do this. The calculator, which I showed you earlier. Math, num, 8, and then just type these in with a comma in the middle. I'm going to do it old-fashioned here. Or you can just start counting by each until you see a number that shows up in both lists. Now, sometimes that'll happen pretty quick, and other times it's going to take a while. Oh, there it is. It's going to take a while. Hardy, can I just multiply it? We talked about this earlier. No, you can't assume that multiplying is going to work every time. Okay, so we're good. Let's look at one more here. Yeah, this is why we can't just multiply them together. 9 and 15. Same idea. Again, calculator, math, num, 8. Type them in with your comma, like we did earlier. If you need to, rewind. So get me on that. I might be nice and do it again here in a minute. We'll see. Yeah, what the heck? I'll be nice. All right. Math, glare. No, math, num, LCM. And again, 9, comma, right above your 7, right there. We can only do 2 numbers at a time, so if we had a third one, we'd have to do this first and then get that third, but there it is. Just making me feel better that I got the right answer. Bam. Oh, we're almost there, people. Simplify the rational trinomial. Okay, now it's actually like, dang, it's actually getting easier instead of harder. That's the right answer. It's because you're getting smarter as you go along here. The confidence is going to grow. So here it's just factor it. Do not cross out the x squareds. Okay. Basically here, I'm just seeing if you can factor. All right, what do I know? Top one in the numerator. Plus on my multiplying number means the signs are the same. The sign is going to be now the sign in the middle, which means they're both negative. So we need 2 numbers that multiply to 45 but add to 14. And if you're not sure, go to your calculator and just start dividing numbers in. Okay, well, 1 and 45 ain't getting me within 14. That doesn't work. 2 gets me a decimal. I'm being your human calculator here. 3 and 15, but they don't get me to 14, but I'm getting close. 4 gets me a decimal. 5 and 9, full 5 and 9, that gets me to 14. So if you got to play with the calculator, do it. If you have a multiplication chart from somewhere, use the multiplication chart, find the 45s, and work your way in from the edges. That's perfectly fine. But we got to, figure that out. Same thing on the bottom. Again, positive multiply, negative add, so they're both negative. What multiplies to 81? Now this you probably know off the top of your head. 9 times 9 is 81. Then comes the issue. When you're canceling, it is 1 set of parentheses to 1. Why do I say that? Because I have a lot of people say, ooh, all three of these are the same. They all cancel each other out. No, they do not. One up top, one on the bottom. If these were the only x minus 9s, let's say this would have been something else, I don't know, x plus 8 or something, you cannot cancel them sideways. We talked about that before earlier too. So vertical, yes. 1 for 1. Don't cancel the x's. Use parentheses. Play it safe. Okay, straightforward things. Let's play with one more of these. I'm trying to see which one. Nope, I don't want to do the same one. That's the same stuff. Well, these are too nice. I'm not going to do all these. Okay. Coming down the home stretch, because we did a lot of factoring already. I'm not going to keep making you go through all that. And again, it gives you some more practice ones to try. Okay, so when we get to here, convert the following log into its exponential form. Okay, I'm going to size this up a little bit. Just a second here. Okay, that should make that a little better. That's better. Log into exponential. You're like, oh, this is kind of like what we were doing earlier. Yes, except now we're going into the exponent form. So when we were doing that earlier, and we're going to pull that up again. Where is my log to exponent help? See, this is why I put these on note cards, because now I can have them when I need them. So now we're going the opposite way. So we've got the log. Okay, we're going to exponent. So let's see here. Let's start looking this out. So base is 5. Exponent. Where's my exponent? Well, let's look. My exponent here is there. So the equal sign, -2 equals n. Okay. You even can label these with numbers. Maybe you do it with colors. That's actually a good idea. Let's do this. So I'm going to have purple to purple. I'm going to have red to red. And we're going to have green to green. Little things like that can make a huge difference, because then when you're trying to redo it, you could literally write this down. I'm going to do it. Let's do this. So I've got log. Okay, got 5. N is green. 25. No, 2. Sorry, gotta get that. And so now I could just look at this and go, same color, there's my 5. Same color, there's my 2. Same color, there's my answer. So you can even color coordinate this to make it easier and not have to worry about it. So that's what we're shooting for. So let's see here. 5. And again, when you're putting this in, you can either use this AB, okay, get that up there, or you can use Shift 6. They both will work. -2 equals 10. Yay! Okay. Then exponential to log. It's just the opposite. So I look at this and I go, okay, I got my handy dandy color-coded example here now that I want to be working with. So I've got 81. I'm just going to color it right away. 81 to the 1/2 equals 9. Okay, color-coded. When I go to do my log now, just follow the colors. Log, okay, blue is 81, green is 9, red is 1/2. Literally followed colors instead of trying to follow base, exponent, and answer. Now, this is where I hope you watch the video and I don't get 15 emails about this. When you go to type your logarithms in for this, okay, hopefully you've made it to the end of the video. I'm even going to put this in the Google stream. I'm putting it everywhere since this is the last problem we're doing. There is not in the typewriter place a place for what's called a subscript. Okay, this little number down here. The only way you can type it in, I'm going to put it all over the place right now. okay, is shift and then the minus negative key that is on your keyboard. Usually it's right next to the 0. So if you do that, if you hit shift and then notice it goes down, I type in my subscript, then I right arrow to bring it back up. That's the only way I've been able to figure it out. I wrote to Delta Math, nobody wrote me back. Okay. So again, I'll say this again. I'll say it when we do review. I'll say it when I post the test and things like that. But that's the only way you're going to be able to put that in there. Okay, folks, I don't know how long I've been talking, but I've really kind of taken some in-depth with all of this. Please take some advice as you get ready for this test, because you get one shot. I'm not resetting tests for people over and over. Do the review, okay? If you've watched this video, that's great. You still need to go through and do some reviewing on your own, because just hearing me talk you through it isn't going to help you when you're actually taking the test. The test is shorter than this. And I think I put in a time limit of like an hour and a half. I mean, I stretched it. I still want you doing it at one sitting. You have to do it at one sitting. So less problems, but timed. Have your stuff organized. The test itself is in the same order as this. So if you have your notes organized from beginning to end, like you do with this review, you're going to have them in order, right, ready to go for the quiz. So hopefully we've done some good training today. We got you good and pumped up. But if you still have some questions, let me know. Good luck. I know you're going to do a super job on this. We'll see you next time.